Okay, let's move on with the graphs of sine and cosine here. We, in the first lesson, talked about graphing your sine and cosine with period and amplitude changes. Well, now we need to see what happens if we have a vertical or a horizontal shift, and then we'll throw all four of them in to one big problem. First, don't forget how to graph just your basic sine and cosine. Sine x, oh, that was terrible. Doing, there we go. Sine x, if you remember, starts at the origin. Then it has its little period, does this thing. It ends at 2 pi. First x-intercept is at pi. The first max is at pi over 2. And your minimum here is at 3 pi over 2. So there's your graph of sine. And it does continue this forever. It doesn't just stop at that one period. And then cosine, you need to know what it looks like. And it starts with a y-intercept of 1. It starts up here. Has that same shape that sine has. It's going to come down, and then it'll finish its first period right here. Its period is also 2 pi. The middle, the minimum point here, is going to be just pi. Our first x-intercept is pi over 2, and our next x-intercept is 3 pi over 2. So make sure you know just your basic graphs of sine and cosine, because without those, you really can't do the rest. So let's start with, let's do a vertical shift. And what I've done with this one is I've actually thrown in a period change as well. If you remember, your period of a sine or cosine graph is affected by the coefficient of x. And my period is going to be 2 pi divided by the number right here. So 2 pi over 2, and we're simply going to have a period of 1, which means 1. That's not right. Period of pi. There we go. Since we are doing cosine, I'm automatically thinking about the shape of cosine. I know it starts up high and it does this little thing. So that's kind of playing around in the back of my mind. Only this one, if you notice, I have a plus 3 on the outside. Well, that, just like any other function, if you remember your transformations, if you add 3 on the outside of the function, that is a shift up 3. So the way I handle a shift up 3, unlike all of the other graphs that we've done where we've done our shifts at the very end, I'm actually going to tackle my vertical shift at the very beginning. And the way I do that, normally when we graph sine or cosine, we center everything on the x-axis. We go above the x-axis and we come below the x-axis. And my x-axis, for lack of a better word, I'll just call it the midline. I don't know if it actually has a name. I probably could research that and give you an answer in about a minute, but I'm not going to bother. Well, if I shift up 3, then that midline is going to jump up to y equals 3. And what I'll do is I'll just put a little dotted line at y equals 3. And I treat this almost like it's the new x-axis. Since my amplitude is 1, remember the amplitude is the coefficient in front, which in this case is 1. That tells me that from my midline, I'm going to go up 1. And I'm going to go down 1, and cosine actually starts up high. So we're going to start this graph up here. This is 1, 2, 3. Up here at 4 is where cosine is going to start, and it's going to come down to 2. So it's going to come down, bottom out at 2, because the amplitude is 1. We're going to go 1 up and 1 down. And then we'll come back up, and I'm going to start like this, and I know that my period is pi. So I'll label my midline. I treat this almost like it's the x-axis. So I'll label my period at pi, and then I'm going to get the rest of my points. The minimum happens right in the middle. And so if pi is where my graph ends, half of pi is pi over 2, and then I cut that in half once more. My x-intercept right here is right in the middle, so I'll come over here and I'll think, okay, what is half of pi over 2? And you get pi over 4. So that is what this x-coordinate is. And then, as I told you in that first lesson, this is your counting number. So I'm going to count up by pi over 4. So I have 1 pi over 4, 2 pi over 4, and 3 pi over 4 is this one. And then I end at 4 pi over 4, but 4 pi over 4 does cancel to just pi. So there's our graph, and that's what we're going to do. I took care of my shift at the very beginning, and this is what our graph of cosine 2x plus 3 will look like. And the period is, I started from 0 and ended at pi. So we still have that right period. Amplitude looks good. And so there's how we're going to graph a vertical shift. Let's try with -2 sine half x minus 5. So I've changed a bunch of stuff. I see my vertical shift. This time I'm going to go down 5. And then I need to identify my period and my amplitude. So my period is going to be 2 pi divided by 1/2. Okay, well, if you divide by fraction, that's the same thing as multiplying by the reciprocal. So my period ends up being 4 pi, which is really nice. And my amplitude is always a positive number. My amplitude is going to be 2. And I know that my graph of sine x normally starts at the origin, goes up, comes down, and does this. But since this is a negative sine x, it's not going to go up. Negative sine x is actually going to start and go down. So this graph is going to start at its original point and then go down because it's a negative sign. Now let's see, I'm going to start going down 5. My midline is going to be down 5. So let's get my axes going. If I'm going to shift down 5, then I don't need a whole lot of room up top. I'm going to start by going down 2, 3, 4, 5. And -5 is going to be where my midline will be for this problem. So there's where I'm going to center my graph. And then I look at my amplitude. My amplitude is 2, which means I'm going to need to go up 2, and I'm going to need to go down 2 from that midline, which is going to put me up here at -3 and down here at -7. We'll see, it's sine x, so we start in the middle. It's negative, so instead of going up, we're going to start by going down. We're going to come down to -7, and then we'll hit the midline again. Then we'll go up to +3, and then we'll hit the midline, and this is what one period of this sine graph is going to look like. And so right now, I've taken care of amplitude. Amplitude is done. I've taken care of shifting down 5. That's done. Now I've got to take care of my period. I know my graph ends at 4 pi because that's my period. And 4 pi is just sexy. It makes this very nice. So if I end at 4 pi, right in the middle of 4 pi is going to be 2 pi. And then my midpoint here is in the middle of that again. So half of 2 pi is 1 pi. And that's what I call the counting number. So I'm going to count up by 1 pi. So 1 pi, 2 pi. This one right here is 3 pi, 4 pi. And that's going to be our graph of -2 sine half x minus 5. I start with my amplitude and my midline, and then I'll come back and I'll deal with the period at the very end. Okay, good? So that's vertical shifts. Let's take a look at some horizontal shifts, because those are a little bit trickier. With your vertical shifts, remember if there's a -5 or plus something on the outside, we started by shifting down, and we did that at the very beginning. With a horizontal shift, we're actually going to go back and we're going to graph the original cosine of whatever first. In this case, it's cosine. Then in the end, I'm going to take care of my shift. And the rules for transformations have never changed. This is x minus pi over 2 on the inside. Remember, if you're inside with the x, you do the opposite of what you would think. So x minus pi over 2, I'm actually going to take my graph and shift it right, pi over 2. And that pi over 2 is the only thing going on. Other than that, this is just your regular cosine graph. So I'm going to go into thinking land. And for cosine, I know we start at pi, and cosine does something like this. So I'm going to start by graphing just cosine, and then I'll come back and I'll handle that shift after I graph cosine x. Okay, so cosine, my amplitude is 1. So I'm going to start at 1. I'm going to come down, I'm going to hit my midline, and then I'm going to bottom out at -1 right here. I'm going to come back and hit my midline, and then I'll finish up here, and my graph of cosine is going to look something like this. Except I kind of wish I made that dotted, because this is not my final graph. I'm going to make this a dotted graph because this is only temporary. We're going to have to shift this to the right pi over 2 units. So what I'm going to do, I'm going to go ahead and label my original points. My period is 2 pi. Middle of that is 1 pi. This right here is pi over 2. And we cross here at 3 pi over 2. And this black graph is just the graph of y equals cosine x. There's nothing fancy with that. That's just your basic cosine graph. Now I need to shift right pi over 2. What I'm going to do, if I shift right pi over 2, that's the exact same thing as adding pi over 2 to all x coordinates. So what I'm going to do is one by one look at these 5 x coordinates, and I'm going to add pi over 2 to each of them. So my first one right here has an x coordinate of 0. Well, if I add pi over 2 to that, that's going to turn into an x coordinate of pi over 2. So at this point, if I shift right pi over 2, it's going to end up at pi over 2 right here. Now I'll move to my next one. See, this one shifted right pi over 2. So now I'm going to look at this x coordinate of pi over 2, and I'm going to add pi over 2 to that, and that's our transformation. Pi over 2 plus pi over 2 is 2 pi over 2, or just pi. So this point right here is going to move to the right to just an x coordinate of pi. So it's going to end up right here. And we're going to do that all the way across. My next x coordinate right here, this point, is at x equals pi. If I add pi over 2 to that, we end up at 3 pi over 2. So this point's going to move over to 3 pi over 2. And we'll keep going at 3 pi over 2. I will add pi over 2 to that because that's my shift. 3 pi plus 1 pi is 4 pi over 2, which reduces to 2 pi. So this point moves over to here. And then my last point, if I shift it right pi over 2, I'm starting at 2 pi plus pi over 2. You would get a common denominator. 2 pi is the same thing as 4 pi over 2. Plus 1 pi over 2 is 5 pi over 2. And that's where this one's going to end up. So I'm actually going to have to label a new x coordinate, 5 pi over 2. And that's where my final point goes. And finally, after adding all of those values, I can connect my new points, and my final graph is that one. This red graph is the graph of cosine of x minus pi over 2. Kind of a pain in the butt. It takes a lot longer. Just start with your basic graph, and then we'll add pi over 2 to all the x's, or whatever the shift is. Let's see, how long did that take? That probably made this a little bit longer, 13 minutes. But 2 more problems I want to do. Okay, let's look at this one. This one's very hairy, a lot of stuff going on. The last one was very straightforward. All there was a shift. This one has some other junk going on. So, let's see, it is a sine graph, so I'm automatically thinking about my graph of sine. I know it starts at the origin, goes up, down, and finishes. And normally it finishes at 2 pi. But we're going to have to change that here. I see 3 things on this problem. First, I see a shift to the right, pi over 4, which means in the end, I'm going to add pi over 4 to my x's. And then, let's see, my amplitude is 3. That's your coefficient in front. And my period is 2 pi divided by this number. So my period is 2 pi over 2, which reduces to just pi. Okay, so what I'll do right now, I'm going to put my shift on hold for just a minute, and I'm going to graph the rest of this. So let's do that. There is no shift, so I'm going to stay centered on the x-axis. I'm sorry, there's no vertical shift. We're not going to go up or down. Let's see, sine starts at the center, and then it goes up. In this case, my amplitude is 3, so I'm going to go up to 3 and down to negative 3. I'm going to go up to 3 and down here, then I'll go down to negative 3, and then I'll go up back to here. And this is what my first graph is going to look like, everything except my shift. That's a really pretty graph. Check that out. So what I have right here, let's label my x coordinates. This is an x coordinate of pi. This right here in the middle is going to be an x coordinate of pi over 2. Cut it in half. Half of pi over 2 is pi over 4. And then that's how I count. So 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4, which is just pi. So there is my graph in black. This is my graph of 3 sine of 2x. That's everything except my shift. I'm going to look at all of my x coordinates, and I'm going to shift them to the right, pi over 4. Alright, so here I've labeled I got all my x coordinates, 0, pi over 4, pi over 2, 3, pi over 4, and pi. I'm going to add pi over 4 to all those. So 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4, which reduces to pi over 2. Pi over 2 plus pi over 4, get a common denominator. 1 over 2 is the same thing as 2 over 4. So 2 pi plus 1 pi is 3 pi. Denominator stays over 4. 3 pi plus 1 pi is 4 pi over 4, which is just pi. And then pi plus pi over 4, get a common denominator. Make that 4 pi over 4. 4 pi plus 1 pi is 5 pi over 4. And so what I've done is I've added pi over 4 to all of my x coordinates, and now we're going to move them. So I was at 0, but 0 ended up being pi over 4. So this point is going to move to pi over 4. My pi over 4 point, I started at pi over 4, but I ended up at pi over 2. So pi over 4 is going to move over to an x coordinate of pi over 2. There you go. And I keep doing that with all of them. Pi over 2 ultimately became 3 pi over 4, so this point is going to move to 3 pi over 4. 3 pi over 4 became pi, and pi became just 5 pi over 4. So I'm going to have to label that one. That's a new point, 5 pi over 4. And then I'll plot all the other ones, and then we can connect them. And this blue graph is going to be our final graph of y equals 3 sine 2x minus pi over 4. So there we go. The shifts are a pain in the butt. Shifts are a pain in the butt. There is, how far have we gotten? 18 minutes? Yuck. These are just some general rules. I gave you the a sine bx and a cosine bx in the first video. I've added the shifts to it. And so here's this graph. These are just your general definitions or general guidelines for graphing trig functions, at least sine and cosine. And so you may want to pause it and write those down. I'm not sure. Maybe you just want to keep it on your iPad, do a screenshot or something. There's one more graph I want to look at, and since I'm already pushing 19 minutes, let's only identify the transformations. And maybe in class or something we'll be able to finish going over this one. So what I've got here is a graph of cosine x, and I'll just go into autopilot. I already am thinking about what cosine looks like. I know that's the general structure of it. We're going to need to identify the amplitude, the period, the horizontal shifts, and the vertical shifts. Now this one is a little bit tricky because before you can identify any kind of shifts, like amplitude and period are not too bad. Amplitude is going to be 1, even though there's a negative 1, but that negative means that we're actually going to start upside down. So it's not going to look like that. This cosine, since it's negative, is actually going to start down low and go up, and it's going to finish something like that. So the amplitude is positive 1. My period is going to be 2 pi divided by my coefficient of x, which in this case is 2. So my period is going to be just pi. And even my vertical shift is nice. I have a plus 4 on the outside. So I'm going to go up 4, but my horizontal shift is tricky. If you remember, before you can identify a horizontal shift, you have to have a 1x. So we've done a few of these, and it always trips you up. But the only way I'm going to get a 1x is if I factor out that 2. So I've got to do 2 times something. Everything else is going to stay the same. But you have to factor out that 2 while leaving it inside the cosine. So if I pull out the 2, I know that 2 times x is going to be 2x. And I've got to figure out plus what is going to give me pi. I think, well, 2 times 1/2 will give me the 1, but I need a pi. So it's actually going to be 2 times pi over 2. And that is going to give me my horizontal shift. So once I factor out the 2, I've got 2 times all of that mess. It's actually a shift to the left, pi over 2, which means I'm going to, in this case, subtract pi over 2 from my x's. Now what I'm going to do, I'm going to pause this so I can graph it, and in a second you're going to see what this graph looks like in case you want to give it a shot in practice. Okay, there, I just finished graphing all of this. This is what the graph ends up looking like. You can see my scratch work for when I subtracted pi over 2 from my x's. The bold green graph is what the final graph should look like. So there you go. This ran a little bit long too, but this is graphing trick stuff is not particularly easy. So hopefully this helps out. If you haven't fallen asleep by now, wake up! All right, we're done.